Hi, today we're going to be going over fractions for the first time, and we're going to be just talking about what they are and as well as some mixed numbers and how to find them. So a lot of people when I talk to and help throughout the years, they hate fractions. However, remember that what I always say, that mathematicians are the laziest people on earth. That doesn't mean that they sit around and eat potato chips and play video games, but we do things the easiest way possible, and that's what fractions are. Fractions are nothing but a division problem that nobody wanted to solve. It's the laziest way to do any kind of division problem. And so if you like division, then these are easy peasy. You can just convert everything over to a division problem and get your decimal. But if you don't like division, then guess what? Your fractions are going to be your new best friend. Everything about a fraction is the easiest way possible to do any kind of division problem. And trust me on this. So let's start with what are fractions. Fractions are just taking things into parts. So let's do something very basic. Let's pretend that this is a cake. And it's my favorite type of cake. It's vanilla cake with vanilla icing. I'm a very plain type of person. Okay? And you and I are going to share the cake together. And we're each going to take one of the pieces. So this is mine. And this is yours. Okay, so a division problem, and we know, and you've known this for years, this is nothing new, that I'm going to have 1/2 and you're going to have 1/2. And we write it like that. Now, let me show you about, and that's just real basic. We're just starting with basic because even if we had tons of huge numbers here, it's no different. So the top number is what I care about. I'm a very selfish person, and I only care about the pieces that I'm going to get to eat. I really don't care how much you're going to get to eat. However, the bottom number is how many are in a whole. In a whole cake. And that's where we get the 1/2 or 1/2. How many I care about and how many are in there. Now, let me show you about what I mean by it's a division problem. Sometimes we are going to have to make fractions into decimals because that's how they want it, or that just is how it's easier in that form. So I'm going to come up here and take the 1/2. Now, if you were in the office with me, what I would have you do is, if it's okay for me to touch you, it would be I'd put my hands on your shoulders and I'd have you fall over. Because trust me, once I do it once, you will never forget. We're going to fall over. So this is going to fall over. Okay? And we're going to put it in a fraction. And I'm going to do that. I'm not going to change the color because that color is a little obnoxious. So what we're going to do is, how many times, what can we multiply by 2 to get to 1? And there's nothing. So we're going to put a 0 there as a placeholder. Now, a real mathematician wouldn't be putting a 0 there, or most of them wouldn't, because anything on a 0 on this side of the decimal doesn't mean anything. But you often have to put that 0 in school because most students, the handwriting is really atrocious and you can't find the decimal point. So that 0 there is just a placeholder so your teacher and you, when you go back to it, know it has an idea where the decimal might be. So now we're going to look, and what times 2 will get you 10? And is 5. We all know that. So that's going to put there, and we're going to have a 0. Now, depending on how many decimals we need, we can just start adding zeros, because at this point, zeros to the right of the decimal don't mean anything. It doesn't change the number. And you know that because you know something that's worth $1, if I wrote it like that, or I wrote it like this, means the same amount of money. So it's really easy. That's why we add zeros. We just add zeros to make it more convenient, or make it so that it's easier to tell what we're talking about. Okay, so we know what the fractions actually mean now. And we know what one looks like and what each number means, as well as how to transfer it into the division problem to get your decimal. So a big thing that people get confused about are mixed numbers. Now, so let me go, we have 2 cakes now. But I'm going to be really, really, really selfish. And I'm going to sneak in before you get into the kitchen, because I'm going to treat you like my kids, and I'm going to take 3 of the pieces of the cake. Now, remember, the top number is what I care about. And the bottom number is the total in, in one cake. So I care about what I'm going to get to eat, and that's the 3 pieces. But there's only 2 in a cake, and this is called an improper fraction because this is more than 1. Now, something that's really interesting, and I've never been able to figure out myself, if you're an algebra student, you have to leave the number like this. But if you haven't done algebra yet, if you leave the fraction as an improper fraction, you're going to get marked wrong. They're going to want to see that as a mixed number. Once we hit algebra, if you leave it as a mixed number, you're going to get marked wrong then because they want to see it in improper fraction. I have no idea why that is, but there you go. So let's change this over to a mixed number. All right, I'm going to flip-flop colors real quick. Let's see if I can find a non-obnoxious one. So the easiest and laziest way to do this is to say, how many times can I multiply 2 to get to 3 without going over? And that's 1. And then what would be left over? 1 piece and 1/2. And we can see that because I'm going to eat 1 whole piece and then 1 whole cake, and then in the second cake I'm going to have 1/2 of the second cake. So this is how many whole cakes I get to eat and how much of a part of a cake I get to eat. Now, a lot of times it's not going to be that easy for you to figure out. So we're going to have to actually do the division problem. And let me flip to that. And I'm going to come up here just because, we need some more room. So I'm going to have our 3 halves. Remember, we're going to fall over. So we're falling over like that. And I don't know why I always just put 2 zeros there, because we don't need 2 zeros. It's just a habit that I've gotten into, that we always go to at least 2 decimal places. But you don't really need to do that. That's just a habit after decades of doing this. So anyway, what times 2 gets you 3? And we all know that because we've already figured that out. But just for the sake of demonstration, 1. So 1 times 2 is 2. I'm going to subtract that out and get 1 as a remainder and bring down a 0. What times 2 gets you 10? And that's going to be 5. And then we have a 0. So we have 1.5. Now, we have 1.5, we have 1 1/2, and we have 3 halves. So let me show you something. These are all the same name. Just like I get called the same name for different situations. My students call me Miss Christine. My mom and relatives call me Chrissy. My kids call me Mommy. So I might hear Miss Christine, I might hear Miss Allen, I might hear Mommy or Chrissy or Christine, but this is all me. I haven't changed. I have just different names for different situations. And that's the exact same thing that's happening here. 1 1/2, 3 halves are 1.5, 3 halves, and 1 1/2 are all the same name for the amount of cake I get to eat. So you just need to know that it's just different names, and there's nothing weird or strange because I'm sure you go by different names too. So that's all we're going to do in this video. What I'm going to do is I'm going to have you go to this next page, and here's some practice problems for you to try. There's only 3. So pause the video now and convert each one of these into a mixed number. Once you get done, press play, and I will have the answers on the next screen. See you in a few minutes. Okay, so you're back. So the answers are for 4/3, it becomes 1 1/3. For 7/4, it's 1 3/4. And for 9/5, it's 1 4/5. Did you get them right? Great job. You can stop the video right now and move on to the next one, or do go on with your day, whatever your parents want you to do. If you did not get those correct, hang out for another second, and I'm going to show you how we got those. Okay, so this is how we got those. What we can do, I'm going to show you both ways. How many sets of 3s go into 4? Well, I know I can do one set of 3, and then I would take 4 minus 3, and there'd be 1 left over to get to 1/3. We can also do that as a division, where we take 3 and we make the 4 fall over. And I'm not going to do what I did. I'm going to stop and not put in 2 zeros. I'm only going to put in 1. So how many what times 3 gets you close to 4 is 1. And we have 3, and we have a 10. So this is going to be quite interesting. At this point, we can take this as our, if they want it in a fraction, we can take this, and this comes up to the top of the fraction, and this flips around to the bottom. But if they don't want that, and they want it in a decimal form, what times 3 gets you 10 without going over, and then we have 9, and we have, this will be a repeating decimal, 3.3.3. It's a rational number, so you can do 1.3, or you can do 1 1/3. Okay, let's go over here. How many times can sets of 4 can go into 7? It's 1, and we take 7 minus 4. There's 3 left over. And we can do that. I'm going to show you how to get the decimal now. We're going to take the 4, and the 7 falls over. And I'm going to put the 1, the decimal there. Always line up your decimal points. What times 4 gets you close to 7? 1. Okay? And then we have 3 left over, just like we have the 3 up there, and we can convert that to the top number and that to the bottom like we did here. Or if we want to do our decimal, we're going to bring that down. What times 4 gets you close to 30? And that's 7. We have 28 with a remainder of 2. And look, now we're going to need that second decimal, and we have a 0, and it's going to be 5. These are just 1 3/4 and 1.75 are just tricky names for the same, different names for the same thing. Okay, how many sets of 5 go into 9? 1. With 9 minus 5, what's left over is 4 5/5. And we can bring that into the decimal. Remember bringing it down. Okay, and we have 1.
You got a group text from Ian Silfies.
Whoops.
Should I read?
Sorry. That was my kids. We have 4.
Did you want to read the group text from Ian Silfies or ignore it?
And then we're going to bring down the 0. So what times 5 gets you 40? And that's going to be 8. Again, these two are the same thing. So watch the video again, or bring up how, if you need more help, bring it up with your coach. Thanks a lot, and have a great day.